In this video, we're going to discuss the Gauss-Jordan method for finding the inverse of a matrix. So what we're going to do is put our matrix A in on the left side of this matrix, and beside that, we're going to write down the identity matrix of the same size. Then we're going to do a sequence of row operations until we produce the identity matrix on the left side. And at the point that we have the identity matrix on the left side, what will appear on the right side is the inverse of our matrix. So when we talk about doing this sequence of row operations, these are the same row operations that we saw in section 6.1. So you can swap two rows, you can multiply or divide a row by any non-zero number, and you can do that third type of operation where we take current row plus or minus some number times our pivot row. So let's take a closer look at why this process here works. So as we turn our matrix A into the identity matrix, you could say what we're doing is undoing A. So we're going through this sequence of row operations that undo A. Now let's think about what that's doing to the right side. So we're starting with the identity matrix and we're going through this sequence of operations that undo A. So what we're building up is the matrix that undoes A. And another name for that is the inverse matrix. So a couple of notes about this process. This works for any square matrix A. So it works if our matrix is 2 by 2, 3 by 3, etc. We'll often use it for the 3 by 3 case because we've got a short formula for how to find the inverse for a 2 by 2 matrix. Second comment, if we see a row of zeros come up on the left side, then that tells us that A inverse does not exist. And we'll see an example of that situation so that we know how to recognize it. So let's find A inverse for the following matrix A. We're going to start the problem by writing down A, and then beside that, writing down the identity matrix of the same size. So we'll just recopy our entire matrix A, just exactly as it was written in the problem. And then beside that, let's remember what our identity matrix looks like. So it's got ones along the main diagonal, going from the top left to the bottom right, and it's got zeros in all the other positions. So our goal here is to go through our usual set of row operations, and what we're trying to get is this identity matrix on the left side. So once we've accomplished that, we will know that we're done the problem. And at the point where we have the identity matrix on the left side, our inverse matrix will be sitting on the right side. So that's what we're aiming for here. So first thing we'd like to do is get a pivot in the upper left-hand corner. Let's do that by dividing row 1 by 2. So we'll have 1, 5, 1. And you want to do that all the way across your matrix, including on the right side. So 1 divided by 2 is a half, and then we have 0, 0. And other rows are not changing at this point, so we'll just recopy those. So there's our pivot, and we can use that now to clean up the rest of that first column. So let's get rid of the 2 by going row 3 minus 2 times row 1. So current row minus 2 times our pivot row. That's going to give us 0. 14 minus 10 is 4. 2 minus 2 is 0. And we're just going to continue that operation all the way across. So 0 minus 2 times a half is negative 1, 0, and 1. And we'll just recopy our other 2 rows at this point. So now we want to move down and to the right from our previous pivot, and this 4 in the center here is going to be our pivot for our next step. So let's go row 2 divided by 4. So we're going to have 0, 1, 1 quarter, 0, 1 quarter, 0. And the other 2 rows can get recopied at this point. So now we've got a nice pivot of 1 that we can use to clean up the rest of that second column. So now we can do a couple of operations at once to clean up the second column. Let's go row 1 minus 5, row 2. So we're going current row minus 5 times our pivot row. And at the same time, row 3 minus 4 times our pivot row. So let's start at the top and go row 1 minus 5 row 2. We're going to have 1 minus 0 is 1. 5 minus 5 is 0. If you have some fractions, you can feel free to do a side calculation here. So we're going to go 1 minus 5 times a quarter. If we put everything over 4, that's like 4 quarters minus 5 quarters gives us minus 1 quarter. So minus 1 quarter is our number there. Continuing across that top row, we're going to have half minus 0 is a half. 0 minus 5 quarters is minus 5 quarters, and then 0 minus 0 is 0. So that's our top row done. Middle row is not changing, so I think I'll just recopy that. And then let's work on our bottom row. So we're going to go row 3 minus 4 row 2. So 0 minus 0 is 0. 4 minus 4, 0. 0 minus 4 quarters, well, that's like a negative 1. Negative 1 minus 0 is negative 1. 0 minus 4 quarters is a negative 1. And then 1 minus 0 is 1. So that gives us our bottom row. So we're almost done now. We're going to move from our previous pivot, move down and right. And so this is going to be the location of our next pivot. And what we'd like to do is just create a 1 there. So we're basically just going to do a sign change on the bottom row. You could say row 3 divided by negative 1, and that's just going to change the signs all the way through. So we'll have 0, 0, positive 1, and then positive 1, negative 1. Everything else in the top 2 rows can just get recopied. And we'll circle our pivot. We're basically 1 step away from being done here. So for the top row, let's go current row plus 1 quarter times our pivot row. That's going to be the right operation to get rid of the negative 1 quarter. And to get rid of the positive 1 quarter, let's go current row, row 2, minus a quarter times our pivot row. So if we can do both those operations, then we will be done. So let's start with the top row here. Row 1 plus a quarter, row 3 is going to give us 1, 0, and then we've got negative a quarter plus a quarter is going to be 0. Okay, then we've got half plus a quarter. So again, just feel free to do any side calculations. Just over here, let's put everything over 4. So 2 quarters plus 1 quarter is 3 quarters. Now we're doing negative 5 quarters plus 1 quarter is negative 4 quarters, or negative 1, you could say. And then 0 plus a quarter times negative 1 is negative 1 quarter. So there's our top row done. And then let's try row 2 minus a quarter, row 3. So 0 minus 0 is 0. 1 minus 0 is 1. A quarter minus a quarter is 0. 0 minus a quarter is minus a quarter. A quarter minus a quarter is 0. And then 0 minus a quarter times a negative 1 is a positive 1 quarter. Bottom row can just get recopied. Nothing is changing there. And the hard work is all done. So notice that we've now produced the identity matrix on the left. We've got the 1s running from the top left to the bottom right, and we've got 0s in all the other positions. So now that we've created that identity matrix on the left, we can say this matrix here is A inverse, and we're done the problem. We found the inverse of the original matrix A. So let's try one more example like that, where we find A inverse for the following matrix A. So we're going to write down our matrix A exactly as it appears in the question, and then beside that we're going to write down our identity matrix of the same size. So 1s along the main diagonal and 0s in all the other positions. Okay, and then our goal is to go through a sequence of row operations, and what we're trying to do is create this identity matrix on the left side, and by the time we get there we will have the inverse matrix on the right side. So let's think about what our first row operation should be. We'd like to get a pivot in the upper left hand corner, and in fact that's already done for us. So that saves us a step of work, which is great. And now that we've got that pivot, we're going to try to clean up the rest of that first column. So try to get zeros in all the other positions. Let's get rid of the 2 in the bottom left by going row 3 minus 2 times row 1. So we're just going current row minus 2 times our pivot row. And let's see what happens as we do that. So 2 minus 2 is 0, 2 minus 2 is 0, and then 12 minus 12 is 0. So something interesting has happened. We've created a row of zeros on the left side. And as soon as you see a row of zeros anywhere on the left side of the matrix, that tells you that A inverse does not exist. The reason is once you've created a row of zeros anywhere on the left, you're no longer able to turn this into the identity matrix. So there are no row operations that we can do at this point to create the identity matrix. Doesn't matter if we tried a row swap or dividing a row or doing current row plus a number times the pivot row. None of those operations is going to be good enough to create the identity matrix. So that row of zeros on the left side is a signal to stop the problem and just say, our original matrix A does not have an inverse. A inverse does not exist. And the same reasoning would apply even if the 0 row came up in, say, the top row of the matrix or the middle row of the matrix. If you see a 0 row anywhere on the left side of the matrix, then the problem stops. So we're going to find A inverse and use it to solve the following system. So first thing we should do is just recognize what our matrix A is. So it represents the coefficients for the system of equations. We just read through the coefficients. 5, 6, 7, 1, 1, 1, 1, 0, 1. All right, so we want to try to find the inverse of this matrix and then eventually use that to solve the system of equations. So let's start the problem by writing down A, and then beside that we will write down the identity matrix of the same size. So identity matrix has 1s along the main diagonal and 0s in the other positions. So first thing we'd like to do is get a pivot in the upper left. Why don't we do a row swap to accomplish that? So let's swap row 1 and row 3. Or alternatively, you could swap row 1 and row 2. But I think I'll just go with row 1 and row 3. So this entire bottom row, this whole 101 plus the right side that's glued to it, all that stuff is going to come up to the top. And then this entire top row is going to go down to the bottom. So the 5, 6, 7 and the 1, 0, 0. Middle row is staying the same. And that way we've created our pivot in the upper left-hand corner. So from there, we're going to fix up the rest of the first column by going current row. Let's go row 2 minus our pivot row, and at the same time let's go row 3 minus 5 times our pivot row. So top row is not changing. I think I'll just recopy that, and then let's focus in on row 2 minus row 1. So 1 minus 1 is 0, 1 minus 0 is 1, 1 minus 1 is 0, 0 minus 0 is 0, 1 minus 0, 1, and then 0 minus 1 is negative 1. All right, let's try the bottom row. Row 3 minus 5, row 1. 5 minus 5 is 0. 6 minus 0 is 6. 7 minus 5 is 2. 1 minus 0 is 1. 0 minus 0, 0. And then 0 minus 5 is negative 5. So there we go. That's our first column done. So now we're going to move from our previous pivot down and to the right, and this is going to be the location of our new pivot. And happily, that's already a 1, so that saves us a step of work. That means that we're ready just to create zeros in the rest of column 2. And actually, one of these positions is already a 0, so that again cuts down the amount of work that we need to do. Only thing we need to do here is row 3 minus 6, row 2. So current row minus 6 times row 2. So let's work on that bottom row. 0 minus 0 is 0. 6 minus 6 is 0. 2 minus 0, 2. 1 minus 0 is 1. 0 minus 6, negative 6. And then negative 5 plus a 6 is going to be a positive 1. So if you want to do a little bit of side calculation here, negative 5 minus 6 times a negative 1 is how we're getting that positive 1. And we can just recopy the top 2 rows because those are not changing at this point. So now moving from our previous pivot down and to the right, this is going to be the location of our new pivot. So we're going to create a 1 there just by taking row 3 and dividing by 2. So we'll have 0, 0, 1. We'll have a half, negative 3, and a half. And we'll recopy our other 2 rows. So very last step that we need to do is just get zeros in the rest of column 3. So it's this 1 in the upper right-hand corner that needs to get fixed up. We're going to go row 1 minus row 3 because we're going current row minus 1 times our pivot row. So let's try that. We'll have 1, 0, 0. And then over on the right side, we're going to have 0 minus a half. So that's a negative a half. 0 minus a negative 3. Well, that makes a positive 3. And then 1 minus a half gives us a half. And other rows can just get recopied there. Nothing is changing in our bottom 2 rows. So now notice that we've got the identity matrix on the left side. And so that tells us that this matrix that's sitting here on the right side is A inverse. So we know that we've found the inverse of the original matrix. So let's remember what the original problem was. It was asking us to do 2 things. We had to find A inverse and use it to solve the system. So now that we've found A inverse, let's figure out how we use it to solve the system. So the formula for solving the system using the inverse matrix is you say X equals A inverse times B. X is your matrix that contains your variables, and it's going to be in the form of a column. So it's just containing the variables X, Y, Z. We're going to write down our inverse matrix that we've just calculated. So minus a half, 3, half, and I'll copy out the other 2 rows. And then that gets multiplied by this matrix B, which represents the constants from your system, and those are written out always in column form. So let's look back at our system. The constants, just the numbers from the right side of the system. So the 56, 9, and 6. So we'll write those down. So now for our last step, it's just a matter of actually doing this matrix multiplication. And what will be coming out are the values of X, Y, and Z. So let's try our matrix multiplication. So we're going to be taking this row with this column, and we're going to be doing our dot product operation. So I'll actually write out all the details of what we're getting in case you want to see what you'd type into your calculator. So you'd go minus a half times 56 plus 3 times 9 plus half times 6. So that gives 2. And so that's telling us that X is equal to 2. Okay, now we're going to take the second row of the matrix and do the dot product with the column. So the operation would be 0 times 56 plus 1 times 9 minus 1 times 6, and that's going to give 3. So that's telling us Y is equal to 3. And then finally, for our last operation, we're going to take the bottom row, do the dot product with that column there. So let's write out what the process looks like. What you would type into your calculator, half times 56 minus 3 times 9 plus half times 6. So that gives 4, and that's telling us that Z equals 4. So we've practiced finding the inverse of a 3 by 3 matrix. And then in this last example, we've also seen really why we care about that, because it then gives us a quick way to solve systems of equations. So that's our video on the Gauss-Jordan method for finding A inverse. Thanks for watching.